Hi, everybody. Hope you're ready to hear about NFTs. Okay, so my name is Antoine Estienne. I've been in the space for 5 years now. I'm a blockchain engineer. I've worked in Ethereum. I've worked a lot in .sama too. I used to work for Consensus and Moonbeam. Now I'm a consultant. And also, whenever I have some spare time, I spend time on several NFT projects. Most of them are on .sama. And today I'm here to talk to you about my main one, my collaboration with Substraknights on the RMRK 2.0 composable NFT collection. So, first thing I'm going to talk about is what RMRK is, and especially what RMRK 2.0 is, which is a nested NFT format. Then I'm going to talk about why and how we chose it to build a new collection with Substraknights. And finally, I will give you some dev tips in case you want to deploy your own collection. So first off, RMRK, what is it? It's a cross-chain NFT standard. So what it means, cross-chain, is that it's basically a standard or a format for a chain of characters. And this chain of character can exist anywhere on any blockchain. It can be transported through bridges or, in the case of .sama, through cross-chain messaging. And that's really useful because it makes it resilient. Basically, we don't have to worry about what blockchain it's living on. Right now, most of RMRK is living on the Kusama blockchain, which is great because we all love that blockchain. But really, it's chain agnostic, so I think it's a good investment for the future. But also what brings us today is the special feature of RMRK 2.0, which is the fact that there are NFT Legos. So Legos are an analogy for what nested NFTs are. Basically, the possibility to equip one NFT into another. So I think this is really powerful, but it's a little bit abstract. So in this presentation, we're going to use an analogy of warriors equipping armor and weapons as an analogy for composable NFTs. So Substraknights, the people I'm working with, I'm proud to say now I'm part of the team, I think, they have already deployed 2 collections on RMRK. And what's great about that is that in our ecosystem, we have already different platforms for NFTs that have different features. So here we can see that the collections are featured both on Codadot and Singular. But today what we're interested in is nested NFTs. So I know that Coda might have some projects in the pipeline concerning that. But what's interesting is that maybe a little bit more than 6 months ago, Singular released a new UI for nested NFT. And so what that means is that we don't have to do the work of building a UI for our project. All we have to do is post NFTs in the right format. So that's why we chose to use that Singular interface and release our own collection on it, which of course required a little bit of work on my part on checking out the open source documentation. So what's great is that RMRK is completely open source and decentralized, so anybody can take a peek at the API, at the example functions, and use them to build our own collection even before our collection was whitelisted, actually, because that's the power of blockchain. You can't stop people from posting on it. So here on that slide, we have the 3 different collections of Substraknights. So what's Substraknight about? Well, as you can notice, there's definitely a warrior theme. It's based around warrior. The first collection, Kusamurai, is about samurais in Japan, medieval Japan. The second one, Kuspartan, is themed around ancient Greece. And the third one is a little bit different. But what's important to understand is that from the beginning, Substraknights is about the .sama ecosystem. And that's why every of those warriors are themed around the parachain. From the beginning, we wanted to show that .sama is a decentralized system by design, and because we have that system with different parachains, different teams, different branding, and they all have a specific goal, and they're complementary to each other, working with each other. And that's what we wanted to showcase at Substraknights. And so the third collection is going to showcase RMRK 2.0 specifically. And I mean, that's why we joined the .sama ecosystem. It's not because it's the biggest volume of NFTs in the world, but it's because it's the most innovative. And that's what's interesting about NFTs. Like, they shouldn't be just a replication of physical art. They should use this medium to transcend the possibilities. And that's why we chose it for our third collection. So here on this slide, some of you might recognize the very famous MMORPG from the 2000 World of Warcraft. We wanted to put it on our slideshow because I think it's a great analogy of what nested NFTs are. Like, most people have never used nested NFTs, but a lot of people have used RPGs. Here we have World of Warcraft, it could be Sims. The idea is that when you start a game, you have a naked character, but you can choose their characteristics, physical characteristics, such as the skin color, their eyes, their nose. But you start with like a very weak shield and a very weak sword and not so nice clothes. And the goal of the game is that you're going to go through adventures, and through game you're going to try to beat a boss, go to a dungeon, and the goal is to earn some new items. They could be weapons or armors, and basically, like, that's what becomes the end game, is that you want to, when you have maxed out your character, you want to have the best items. So that's what we can see on the right, the legendary armors of World of Warcraft. And what's interesting about it is that it's all about gamification. Like, for some people who've never played an RPG, it might seem a little bit ridiculous to think that there is value to a virtual sword, but for people who have played for hours this game, like, those armors and swords are worth a lot, and potentially that's a huge business for NFTs. And so that's why we decided to use more or less the same system in our new collection. So here on this slide, I'm going to explain how the RMRK 2.0 standard works, basically, because we had to use that standard to create that game. So there are three parts, right? So the first part that you see on the left is what's called the base NFT. So basically the picture is just a preview. But what's important about the base NFT is that in the base NFT you will write all the specifications for the different available fixed rates and slots in your collection. And those are going to be fixed for the whole collection. That way everybody's abiding by the same rule. So what does it mean fixed rate? What does it mean slots? Well, so that's, so the vocabulary is not very definitive, but basically what's powerful about this format is that you have fixed rates that once they are attached to a base, they cannot move anymore. So the analogy here is it's the mouth, it's the nose, it's the skin color, like all those features are something that you, as your character or yourself in reality, you will never be able to change, or I mean, at least mostly. And then you have the nested slots. So nested slots are available slots to equip items. So that's what we see on the right. We have a warrior that is dressing up with clothes, armor, and finally a weapon. And so that's also something we have to decide from the start. And all of this is coded in the RMRK code. And that's how basically we design our new CUSA Marauder collection. So we're really proud to say that we've already minted 150 soldiers, CUSA Marauders. We have 57 different owners. And even though these are hard times, I think that people are enjoying very much a lot of the gamification around it. So how it works is that the previous holders of CUSA Murai and Spartan are airdropped a CUSA Marauder, but they also get unique equipment. So you can see the branded shields, the katanas, and those are useful for your character to be able to beat the monsters, because every week there are events where the players can fight against monsters or a boss, and there's even PvP, and basically that's why people are playing, because every week they want to have the thrill of knowing whether or not they will get items and whether or not they will be the winner of the tournament, and if they do, they earn items that we can mint through the API and distribute very efficiently thanks to the API. So I think it's really a game changer for us, because before there was a different utility, and now there's a clear gamification, and that was really helpful for the CUSA Marauder collection. So now I think that it's not that hard, actually. I mean, somebody has to know how to use an API, which requires some coding experience. But once you do, I think it's completely possible to deploy your own collection, provided that you're collaborating with a designer, of course. So here are a few dev tips for somebody who want to do that. So the first one is I recommend that you create one collection per slot. So the way it works is that, for example, in our case, we're going to mint a naked soldier that is going to be equipped with 8 different fixed traits that are basically their appearance in terms of skin color, mouth, hair, and so on. And then we're going to equip them with starting items. And all of those are in different categories too. We have weapon, we have arms, legs, and so on. And for the user to shop through this, if they want a better user experience, it would be much better if everybody had a different collection, because we don't want to see a background mixed with a sword and so on. And what we do want is users buying our stuff, of course. So one slot, one collection. Tip number 2 is to index your nested NFTs. So in our case, we are making an RPG where there are going to be duplicate items, such as the starting shackles, for example, because our characters start in a prison. But the nature of NFTs is that they should never be duplicated. So what we did is that we added indexes to those duplicate elements. That way they're not actually duplicates. This is getting a little bit more technical. I'm a big fan of TypeScript myself, but it's true for any type language. What's great is that RMRK has a TypeScript API library module. And using TypeScript really helped. Why? Because the code can be quite complex for the whole deployment, and we don't want to confuse the slot with the fixed trait. We don't want to confuse the description with the file name, because this could cause an error, and having just a tiny error can force us to remint a whole collection. So when we use strong types in coding, this prevents a lot of errors. It also prevents spelling mistakes if we force a limited number of slot categories in our type files. And for those who are interested, that's something that you can see in our open source repo that we'll talk about later on. Also, one interesting to know about what I love about TypeScript is that if you want to add a different description than the file name, for example, which I didn't do yet, you can just change the type, and the editor will show you everywhere where you should modify your code to add that different attribute. So that's really useful. Well, finally, I mean, that's obvious, but you should plan ahead. By nature, from the base, the number of fixed rates and slots is fixed. And in our case, we wanted to allow our characters to have pets or mounts, but we didn't want to start with that, just like in World of Warcraft, actually. But we had to plan that ahead, and that's what we did. We added 2 extra slots that are not used yet, but that will be later on. Well, so testing, this again seems obvious, but even though the code looks great and TypeScript is tight, it doesn't prevent all errors, so I think one should use a testnet. I think one should use some testing scripts. And here, what we have is our guinea pig warrior that we used for testing. He's been born and died, burned many times. So we really thank him for his sacrifice for science. All right, so now we're getting at the open source repo part. So for those of you who are not afraid of reading markdown files, I recommend you go check out our repo. It's in the dev branch, in the script branch. So it's a fork from the RMRK 2 example that was created by the Singular team, the RMRK team. What I added is, well, basically more complex use of types and deployment. So I'm not going to go into details, but basically there's a script to generate your randomized fixed rate collection. There's a script to mint the soldiers, and there's a mint to add the items. There's also a script that's used to send items to soldiers, because not all the features of nested NFTs were implemented yet in their interface, so we had to improvise a little bit. Want to add something. What's really interesting about fixed parts, in my opinion, and is underrated in the RMRK 2 format, is that it allows to make generative collections. So of course, that already exists a lot. Generative collection, the concept is you have random traits for a character or PFP, and you can make 100 or 1,000 different randomized combinations. Some of are more rare than others. But what's great about doing it with RMRK 2.0 is that it's completely programmatic and API-based. That means that as a coder, I don't have to think about creating a script that will layer the SVGs, because the user interface of Singular will do it for me based on the RMRK format. And so that allowed me to create really easily this completely randomized and generative collection of 150 CUSA marauders. We are aiming at going all the way to 500 for this collection. And yeah, so I recommend exploring that fixed part aspect as much as the slot aspect, which is also really interesting. Okay, so now we're getting to minting, the most interesting part, the scariest also. There are a lot of functionalities on the interface that allows saving time, but also it's important to talk about batch transactions, because one doesn't want to watch their computer mine for hours, so we're trying to increase the throughput. The problem is that it takes at least 4 transactions to mint a full soldier with items on. We have 1 transaction to create the base, 1 transaction to add all the fixed traits, 1 transaction to create the items, and those can be all minted at the same time, and then 1 transaction to equip them on the character. But we can parallelize this process. We can totally mint 10 soldiers at a time, 10 bases, equip all of them, create all the items, equip them, and so that would be 10 soldiers for 4 transactions. The problem is that there are limitations to this, because we might hit some rate limits. So For this project, we use Pinata to host our pictures. So it's really important for an NFT project to host your own pictures, because if you're using a centralized service, well, they could be erased at any time. So Pinata is an IPFS hosting service. It's not absolutely perfect because they could be hacked and the IPFS node destroyed. But what's great about IPFS is that once we have the CID of a file, we can ourselves duplicate it into another service. And already Pinata allows duplicating your file on 2 different nodes for free. Also, we use one of their services called the dedicated gateway. The advantage of that is that we have unlimited read requests. That's important because, of course, our collection is so popular that we have thousands of users flocking to the platform, checking the picture and basically sending a read request to the IPFS network. Singular has been hosting the pictures themselves for a while, but I don't think they will do it forever because it costs them a lot of money, and eventually all NFT creators will have to host their own IPFS pictures. The big problem with Pinata, though, is that there's also a rate limit on the number of writes, and that's what limited us in the minting, because you have to think about the number of different pictures that you're going to upload. In our case, we have about 8 different fixed rates on a character, about 9 different nested slots. So it's about 18, counting the base, 18 different images, 18 separate NFTs that are minted for each soldier, and that means 18 requests. So if we mint 10 soldiers, that's 180, and that's already the rate limit of writing to Pinata through, writing to IPFS through Pinata. So that's why we had to limit the throughput, and that's a parameter that I put in my script. So that way we can mint 2 soldiers at a time if we have low throughput, or 4 or 5 or more if the throughput is bigger. And I think we're reaching the end of this presentation, because at this point, if you've been following, you should have your own RMRK 2.0 nested collection. And I hope a lot of people are going to come into the space and create their own nested collection. And because, I mean, I think that's the whole point of the metaverse, is that we want to allow people to build their own world very easily without barriers to entry. And I invite all of you to do the same. Thank you very much. And also, thank you, Codadot, for inviting us here. I don't know if there are questions.
Hi. Thanks for the great presentation. Can you elaborate a little bit about the relationship with the fractional NFTs, just to make it clearer? So let's say the nested NFTs and fractional NFTs, how that could fit there?
What's the second one?
The fractional NFTs.
Yeah, so actually there's a vocabulary problem in the space, I think, because we are not really decided on the vocabulary. There are composable, nested, fractional NFTs. I think they all mean the same thing. I think eventually there will be a consensus on what word we use. But it's always the idea that NFTs are like a tree structure, and some NFTs are nested into other NFTs, and they can be themselves nested on other NFTs, although right now it's a bit more simple than that on RMRK 2.0. But I think they're the same, or maybe you're talking about something else when you're saying fractional NFTs. I'm not sure.
I think it's different. For the nested NFTs, it's that you create your hierarchy, right? That you have a base, then you have some addendums, and while for the fractional NFTs, it means that you normally you have to buy the whole NFT or keep the whole NFT as for yourself. Your address, actually, your account has to have that. And the fractional NFT means that you can that you can split it into the fractions which can have a different owners. Okay, but for me, the nested entities is quite a new concept. So I would like to understand a little bit whether they could work together, basically, these things, because sometimes when the NFT itself is very expensive, then you basically have several approaches how to get that. Either you create the DAO to actually have like one account to purchase it, or vice versa, you make the fractional NFT and you allow several accounts to actually own the NFT.
Yeah, no, indeed, it's different. Like, so in nested NFTs, all the NFTs have to belong to the same person or the same address. Then, of course, the address itself can be a DAO, can be fractionized into multiple owners. I think it would depend on the application. In our case, it's an RPG. The goal is that we would rather have more items that are cheaper because really we want to create as much volume and as much game as we want. It wouldn't make sense for people to co-own a warrior because that would prevent them from playing. So we did not really implement that, but that could make sense for NFTs that are worth way more money, yeah. Any other question? Great. Well, thank you everybody for coming.